In this video, we're going to work area moment of inertia, example problem 2, which is a fairly complex composite shape that's made up of a triangle, a rectangle, a half circle, and a hole. So teaching you how to use different shapes plus a hole, how to handle them. So what we have here is a composite shape made of a rectangle, 4 centimeters by 6 centimeters, a triangle, 3 centimeters by 6 centimeters, a half circle with a radius of 2 centimeters, and a circular hole with a radius of 1 centimeter. We want to find the I about the x-axis and the I about the y-axis. The parallel axis theorem says that the I about the x-axis, for example, is the sum of the I bar plus the AD squared term for each of these subshapes. So the first thing you need to do is think about how can I divide this area into known quantities? And for different problems, some of you might approach them differently. So there's not like one way of working a given problem. So pick a way that works for you. Pick a way that makes sense for you. For this guy, I divided him up into a rectangle, a triangle, again, the half circle, and a hole. Just as a reminder, we're actually going to subtract the whole term. The other thing to note is if a shape touches an axis, then it's easier to use the I-base formula if it's on your crib sheet. And so about the x-axis, my rectangle touches the x and he touches the y. So I can use the I-base for the rectangle about both the x and the y. The triangle, he touches the y, so I can use I-base about the y for him. He doesn't touch the x, so I have to use the full-blown I bar plus AD squared term for this triangle about the x. So think about your strategy as you start one of these problems and make sure you cover your bases. So about the x-axis, and I like to group them term by term, and sometimes I actually draw a picture with each term that helps me realize which term is which for double checking purposes and for completeness purposes. So about the x-axis, if you start with the rectangle, his base is 6 and his height is 4, and the I-base formula for a rectangle is 1/3 base times height cubed. So 1/3, 6, 4 cubed. The triangle about the y-axis, I have to use I bar. So the triangle, the I bar for a triangle is 1/36. Base relative to the x-axis is 6. Height relative to the x-axis is 3. So 6 times 3 cubed, plus his area, which is 1/2 of base times height, 1/2 of 6 times 3. And then the distance from the x-axis up to him is 4 plus 1/3 of 3, which is 1. So the distance is 5 squared. So those are my triangle terms. My half circle, I have to use the I about this horizontal axis, and that I is pi over 8, r to the 4th, or 2 to the 4th. But then I need the transfer term to get from his centroidal axis down to the x, and that's just 2. So the area is pi r squared over 2, or pi times 2 squared over 2, and then 2 is the distance from that axis down to x squared. And that's my half circle. Then finally, I subtract off the whole. So I subtract the I bar for the whole is pi over 4, r to the 4th, plus the area of the hole, which is pi r squared, times the distance squared from the center of the hole down here, which is 2 squared. And so if you do the math for each of these terms, and again, I'd like to write each term out separately, just if the answer turns out strange, it gives you a chance to check term by term. And so it's just easy to get confused stringing all these calculations together. So it really doesn't take much time to write these out. And I think you're going to get the correct answer faster if you do it that way. So So IX is 398.1 centimeters to the fourth. About the Y-axis, so the rectangle touches the Y, the triangle touches the Y, so both of those I can use an I base. I need to use the half circle at a different orientation and take that all the way to the I base, or take it all the way to the Y, and then I subtract off the whole. So that's my strategy. So my rectangle is 1/3 base, which is now relative to the Y-axis, the base is 4, and the height is 6. For my triangle, my formula is 1/12 BH cubed. And so relative to the Y-axis, the base is 3, and the height is 6 cubed. For the half circle, the I bar about this axis that's parallel to the Y is 0.1098, 2 to the fourth, plus the area, which is pi r squared over 2, or pi times 2 squared over 2. And then the distance from the centroid of this guy all the way to here is 6 plus 4r over 3 pi. So 6 plus 4r over 3 pi is this guy. And so 6 plus that is 6.849. And I'm going to square that. And then I'm going to subtract off the whole. So the I bar for the whole is pi r squared over 4. The area is pi r squared. And the distance from the whole to the y-axis is 6 squared. So AD squared, the D is 6. If you evaluate all these guys term by term and do the math, I get IY is 524.6 centimeters to the fourth for IY. So this illustrates how to use the parallel axis theorem for different shapes, different distances from the X and Y axis, and also using the I base forms, and also how you subtract off a whole if a whole is present.